Hello, hello. So, we're going to pick up basically where we left off. Full disclosure, I've never made a Terraria clone in C++. I did follow a tutorial series a long time ago. If we go to YouTube here, this was in C# and Unity. Go to Aaron Does Stuff. He, perhaps I go just kind of looking. Aaron Code, my bad. So he's made a Terraria-like game in C#. And I followed this a little bit a long time ago. This will be tough. Like I said, I've never done anything like this, so I will be learning along the way. I will make mistakes. Sometimes it will take me some doing and redoing, but we'll make it there. So wherever you put this file location at, go ahead and find the solution. Double click it, open Visual Studio, and just to make sure things are still working, go ahead and go to debug, hit that, and we should see this window pop open. What we're going to do today is a little bit of file organization and terrain generation. I'm going to come over here to the header file. I'm going to right click, I'm going to click add, new item, and here let's call this, what would be a good name for this one? Let's just call it game and do .hpp. Alright, so created this header file, and what I'm going to do is basically we're going to place a lot of this over here. Let's say make a class, we're going to call it game loop, and I'm going to do a void return type and call this let's call this trying to think of a good word. Let's just say scene. So we're making a function called scene. I'm going to go over here. We're going to take everything that was in this main loop, control exit, and control V it inside here. I'm going to hash include SFML, graphics, HPP. This stuff should fix itself. And then over here, we're just going to do a hash include. I'm going to hit the quotations is where we're going to be including this, and type in game. You should see it pop up, game.hpp. And we're going to basically instantiate or create an instance of game loop over here in main. So I'm going to say game loop, we're going to call it loop, then I'm going to go loop dot, and notice nothing's coming up. This is because we never made this stuff publicly accessible. So type in public, colon, come back over here, and now do dot. We'll see scene pop up. So go ahead and go like this. And now when we hit play, same thing should happen. We have the window. The reason we did it like this is we want to kind of keep our game logic separate from our main. We only want main calling the start, so to speak, of our game. Now, we're going to do a few different things. So, I'm going to type in void init. I'm going to type void update. And I'm going to type in void drawable. reason why is over here in scene, above the first while loop, this is where we're going to call initialize. Here in the while loop, above the event, is where we're going to call update. And in between clear and display is where we're going to call drawable. This kind of keeps our logic separated. It also makes sure that scene stays relatively clean. We don't want to be putting a bunch of stuff here and here. It just does not look very, it becomes unmanageable pretty quick. And that way we're kind of just filling up these areas over time. And with that said, we're gonna, like with update, we need to create a way to manage delta time. So down here, I'm gonna type SF : clock. I'm gonna call this main clock. And then I'm going to do SF : time, and I'm going to call this delta time. Inside our update, I'm going to say delta time equals main clock dot get elapsed time. And then I'm going to hit enter a few times, and down here I'm just going to say main clock dot restart. We're going to be passing in delta time as a parameter for update within other areas, and we'll see this in time. So yeah, this is what we're going to kind of leave alone here. This is our game loop. I'm going to come back over to header files here, go to file, add new item, and we're going to do, let's see, I'm wondering if we should try player before terrain generation, just to get you guys having something moving on the screen quickly. So I'm going to type in basic entity .hpp. Enter. So we have a basic entity header file. I'm gonna hash include SFML graphics like this. Make a class. I'm gonna call this class basic entity. Public like that. We need a semicolon here. That's why it had an error. We're going to make a constructor. So basic entity like this. And down here, we're going to have a init, a update, and here I'm going to pass in SF time as a reference as such, and then you guessed it, we're going to make another drawable. Looks like I misspelled that. Now for these, especially update here, I'm going to put this virtual keyword here. This way, when we have things inherit from basic entity, we can change update. This is going to be useful later on. For now, down here, we're going to say SF : rect and take this rectangle shape, and I'm just going to call it body. Let's see what else we're going to need. We're going to need some type of bool of, well, I might be getting ahead of myself. Let's think about some type of collision check. You know, I think we can go ahead and do that too. So down here I'm going to do void collidable, because we want all basic entities to know what collision is. And we're going to do a bool down here, is collide, or is collided, and set that equal to false. As a parameter in collidable, I'm going to pass in a rectangle shape reference, and we're going to call this other. And here we're going to say if body dot get global bounds intersects with, and inside of this brackets we're going to say other dot get global bounds. Then we're going to just say is collided, is collided, what the heck? I'm just going to copy it like this, is true. Another way to go about this, for this void type, go ahead and make it a bool. We're going to say return true. And that way we can pass that into this. So we have a body, we have a bool, everything in the game, mind you, not everything, but most things that are an entity will have to have some type of movement, not necessarily the blocks, but so I'm going to say float, movement speed. Go ahead and set this to 0, it doesn't really matter over here. And yeah, that's what we're going to work with for now. So over here in drawable, I'm going to pass in a reference to the render window, call it window, and I'm just going to say, oh yeah, that's the other bool. Sorry for jumping around a little bit, but make another bool called is active, set it equal to false. And up here in drawable, we're going to say if is active, so if our object is alive, so to speak, then we're going to say window.draw and pass in the body. Over here in initialize, we're going to say is active is true. And for now, we're going to just say body dot set fill color. We're going to give him a color of green. And then we're going to do setting his size. So set size. I'm going to do an SF vector. And inside this, I'm going to just pass 20 by 20. And then body dot scale, and we're going to do a 2 by 2. So we have an initialize, we have a draw, some type of function for later, and inside of basic entity here, the constructor, I'm just going to pass in initialize. Now you don't have to do it like this, and for example, we're going to take it out for a minute and go over to game.hpp. So up here, instead of including basic entity and then pragma oncing and all this, we're actually just going to include basic entity straight up. And we're going to come over here to down here below. And let's see, we're going to, for now, just say basic entity pointer, and we're going to call this entity, or just to specify, we're going to call this test. Inside the init, we're going to go test.init, and it's going to become an arrow. That's fine. Also, right above init, go ahead and say test is new basic entity. So we are instantiating, we're then initializing. Over here in drawable, go ahead and say test.drawable, and we'll notice we have an error. Up here in this drawable, also pass in a reference to the render window, and then pass that window in here. We're going to have one more error. It's down here in scene where we called this. Simply pass in the window. This is the window that we created here. One thing I know that's going to happen is he's going to be in the top left corner. We're going to hit play. I'm going to kind of show this, right? So he's there. This is because we never set his position. So over here, body.set position. Then I'm going to pass in a vector, and we're going to say 200 by 200. Hit play, and we should see him. Right. But that's boring. He doesn't move, right? So let's come over here, and we're going to do a very simple if, and then we're going to say SF : keyboard, then : is key pressed, and I hit tab again, do this. Then I'm going to say SF keyboard again, and then we're going to say W. So if the keyboard's button W is pressed, then we're going to do body dot move. We're going to pass him in a movement speed. Now this is the upward movement. So I'm going to do 0, comma, like this. Now there's a few things we have to keep in mind here. We need to be moving the player by delta time. Also the coordinate system. Down is positive, up is negative. W is typically up, so I'm going to pass that to negative, and I'm also going to multiply by delta time, and we're going to see an error. Go ahead and hit a period and go by as seconds. So now we have this. I'm going to Control C and go again. We're going to change W to S. I'm going to come down and make this movement speed positive. I'm going to copy both of these and then change 1 to A. I'm going to come down here. I'm going to make comma 0, and then we're going to erase this one, so this is moving left. And then over here, same thing, comma 0. Come way over here, and this one's moving right. And so we need to change this to D. Now, this will allow diagonal movement. We're not going to allow that. So I'm just going to type in else. And also keep in mind, we're probably not going to have typical down movement, as this would be a Terraria clone. And so in this update, if we go ahead and hit play, you'll notice he still can't move. That is because we never updated him. So here I'm going to go test.update, and we're going to pass in delta time. And if you hit play, you'll notice he still does not move, right? This is because movement speed is equal to 0. If we come over here into our initialize, go ahead and just say movement speed equals, try like 200. Hit play, and he moves. And no diagonal movement with the way we have it set up. So okay, we got a box guy. He will move off screen. That's fine. But we also don't want this to be the player. We want this to just be the entity, so to speak, the basic version of. And so we're going to go over here to header, new item. So add new item. I'm going to type in player.hpp, and here we're going to actually hash include the basic entity. We're going to come here and we're going to do class player, then do a colon and type in public basic entity, just like that. Then we're going to do public. I'm going to type in void update, but then in here I'm going to past this, I'm going to type in override. Then we're going to see that turn red. Go ahead and pass in time, and we're going to call it delta time. What this does is overrides the function here, and I'm actually going to take all this stuff, Control X, and we're going to put it here. I'm also going to make a player constructor and do colon basic entity and do that. I believe that should be fine. Just checking here. Boo, boo, boo. Looks to be fine. We're actually going to take movement speed out of here, and we're going to come over to player, and I'm going to put it there. And just to show you, we're going to do like 500. I'm going to go ahead and save. Come over to game, and instead of inheriting basic entity, we're going to type in player, and instead of this stuff here, I'm going to kind of erase that stuff. Here we're going to actually call this player, and same thing, player dot, and as you can tell when I do this, we have those features available. Again here, like player dot update, pass in delta time. In here, player dot drawable, and pass in the window. Go ahead and hit play. And we have an issue. It says exception thrown, right axis violation. This was null pointer. Take a look. Is active. Boo boo boo. Player. I'm going to go ahead and hit the stop. I'm going to Control X that. We're going to come over here to the player constructor and see if this makes any difference. Go ahead and hit play. Again, we have exception thrown. All right, fantastic. So we have our first little error. Just going to kind of take a quick look here. I almost wonder if that part is necessary. Just check in. What I'm going to do is I'm going to look at a reference that I have made. So I'm going to come over here. And we're going to look at kind of like what I have set up here. And then we're going to go over here to player. Actually, it would be entity in this case. Okay, I think maybe we're going to start with that. Come over here, just kind of check. Exception thrown. just kind of checking to see what the exact differences are here. Oh, that's kind of funny. That's actually very humorous, right? So here we made a pointer. We never instantiated them. So new player. Yeah, that's kind of silly. See if this fixes it, and it does. How did I figure that out? It just kind of hit me. I was looking here, and I realized, yeah, we missed that. It happens. No, this is like I said, going to be a learning process. So as we can tell, player basically behaves just as basic does. This allows us to have different monsters potentially in this game, and this will kind of keep things a little separate, right? Different movement speeds for different entities, so to speak. But now we're going to get into terrain generation, and this video is going to be a little bit on the longer side, so we're already about 27 minutes or so. Oh, and we got like the player sort of kind of set up, right? Kind of shows like a little bit of a project organizational flow, but we need to start defining what is a kind of like a block or 2D cube in our game. So I'm going to come over here to header file, add new item. And we're going to call this we're just going to call this a block. Block dot HPP. So my idea here, so I'm going to hash include SFML graphics, and eventually we're going to kind of organize this properly, make sure it's coming from one area and so on and so forth, or pragma oncing here or there. But we're going to define just what is a block. Like what makes up one little instance. So here I'm also going to have an initialize. We really don't need an update, but I'm going to make a drawable. I'm going to hold control and hit KD, like K then D pretty quickly. That's what that does, is like formats your text in case things get a little wonky. Inside drawable, of course, pass in the render window reference. But what is a block, right? So we're going to come back to SF, rectangle shape. We're going to call this block shape. Inside initialize, go ahead and do block. Go ahead and say block shape. Dot get or set fill color. So we're basically going to do a very similar thing that we did for the player. Do color, make these ones blue. Do like the block shape. Dot set. Let's do set size. Make these. Let's do the size of the player that we got. So 20 by 20. Make sure this is stored inside the SF vector. So 20, 20, and then block shape dot set scale. And let's do like a 2 by 2. And this is relatively fine. In fact, we're going to make a constructor, and instead of having the initialize set this stuff up, we're actually going to pass that work off to the constructor. The reason being is in initialize, we might want to, in this case, set the position of this block in our game. So here I'm just going to go ahead and say block shape dot set position SF vector 2F. Now remember the player right now is at 200 200. So let's try 200 300. And then under drawable here, go ahead and just say block shape or window dot draw block shape. So block shape. So this is one block, and we're gonna do this slowly, step by step, and it might seem convoluted at first, but I think this is going to be a fair way to go about this. So down here, make a pointer, call it block. Notice it doesn't know. So here for simplicity, we're going to go pragma once, and I'm going to do hash include block.hpp. Remember how I messed this up here, so let's be careful and aware of this. So let's do block equals new block, and then do block.init, and down here in drawable, not below player, but above player, do block.drawable, and pass in the window. Hit play. Now we should see a blue, and when we walk towards it, we're going to go right through them. No collision, right? Yep. Well, let's get to that. When we collide under basic entity here, we need to know this stuff. And so for block, it would be really nice if he also was basic entity. So we're going to inherit, we're going to say public. And in this sense, it's kind of funny. Our body here, so like where we're doing a lot of this stuff in the init, this stuff in the draw, so on and so forth, I'm going to take all of this out, control exit, we're going to come over here to player, and we're going to set that over there. We're going to say the is active though over back at basic entity, so every time we initialize is active is true. For the player in particular, we want this color. Now for the block in particular, we have this color. This will be an issue here. So suppose for now we're just going to go like this and get rid of that in it. Just check in, hit play, see what happens. Okay, we still have this. The reason I'm doing it like that is over here in game, go ahead and above update, do void on collision. So kind of like Unity, on collision enter, on trigger enter. We're just making a function called on collision. We're going to say player dot collidable, and we're going to pass in block dot body. And remember this collidable function, he actually returns, or he, she, whatever, that function returns a bool, true or false. and we also have a is collided here. So under game, we're going to just up here go player dot is collided is set to this. And so, for example, up here, I'm going to do hash include stdio. This is the standard input-output library. So if player.collided or is collided is true, we're going to say printf, and then however we want to go ahead and test this. So hit play. Notice in the console, nothing is happening, still nothing, and still nothing. So we're going to check here. Why did this not happen? Because we're not updating this. This isn't happening anywhere. So if we Control C that, after player update, go ahead and call that function. Hit play. Check in the console. When we connect with blue, we still have nothing happening. Interesting. So on collision is being called. Just check in. We're going to try going like this for a minute. Because, yep, so that's false. I'm going to specifically say true like that. We're going to take a look over here at basic entity. If the body's global bounds intersects the other body's global bounds, return true. That's kind of interesting. If is collided is true. Player.collidable. Just kind of looking here. Thinking it has something to do with our inheritance structure. Yeah, it does. So remember how he made this block shape. That technically is a body. I don't know if this is going to make much difference, but we'll see. I couldn't imagine it being so much of a difference there. Oop. Again, I had a weird error. I'm just going to go ahead and type body. Double click, thank you. Boom, boom, boom. Hit play. Ah, there it is. Yeah, that was kind of peculiar. I'm not quite sure why it didn't enjoy the other way. Seemed to be fine, but such is life. So as we can tell, we have a collision thing. We're right now just printing if it's colliding, and instead of that, I'm just going to say, and so this is going to be kind of maybe a terrible way to do collision, but over here under player, I'm going to say bool is is moving right, and bool is moving up. And I'm going to hold Control and Alt and click here as well. So now I have two cursors. I'm going to set those both to false. Just for sake of simplicity, we're going to say left and down. And I'm gonna just organize it a little bit, right? Up, down, left, right. Rolls off the tongue better than up, down, right, left. So we have that. And then while we're moving these things, so I'm gonna just kind of like copy everybody like this. I'm gonna do the Control Alt and make multiple cursors here, like so. We're gonna erase all that. Copy this and go here, do also the Control Alt here if we wanted, Control V. All right, so now we have all this, and of course if we are key pressed is W, we want moving up to be true. If key pressed is S, we want moving down to be true, so I'm going to do the Control Alt again and grab like that. A is left, so here, and then D is right. So we go here and type in true. And basically we're setting one to true, the others to false. The reason being we're doing it like this is over here in the collision. If collided is true, we're going to check something. We're going to say if player dot is moving up is true. And we don't need those these guys here. Then I'm going to say player dot body dot move. And so remember, up is negative, down is positive, and we're simply going to say if we're moving up and we collide with an object, then we are going to move down by the same speed, so movement speed and multiply by delta time, dot as seconds. And then we're going to do the same for the others. So this is if moving up. We're going to have one for moving down, moving left, and moving right. So if we are in the downward movement, then we're going to go negative. If we are moving left, we are also going to go negative, but we want that in the X direction. And then if we are moving right, oh, and I can see a, a little mistake here, right? Because we're moving left, we're already moving negative. We want to then move the opposite. Sorry for any confusion there. That way, if we're moving right and we collide, we are pushing back like this. So now we hit play, and we're going to come down and notice we collide. If we come over to the left and we push in, again we stop. If we are coming up, we stop, and if we come over, we stop. And notice it doesn't really matter if the, like right there, we still have a collision, and about right there. And so this isn't good collision. This is like a very basic AABB collision provided by SFML's get global bounds intersects, and we're simply doing a really poor, very poor check of, hey, you know, if we're colliding, move the opposite that we're trying to move from that direction. That's why we kind of did the bools of that type of stuff. So yeah, now we got collision with these blocks here. However, that's not just the terrain, right? The terrain is going to be a lot of blocks. Yeah, a lot of blocks. So how are we going to handle that? Right? We already have some inheritance, and the deeper and deeper it gets, it's going to get kind of funky, right? Like, are we going to have somebody inherit from block? Likely not. What I'm going to do is in the same file here, I'm going to come down here and we're going to make a new class. And we're going to call this terrain. Go public. And within this, we're actually going to just take in an instance of block. So like block pointer block. However, this is where things are going to be a little bit different. And in fact, I'm going to take a little bathroom break. I'm going to pause the video, and we'll be back shortly. And with the magic of video editing, we are back. So, one thing to keep in mind is we might not know how many blocks at first, right? Like we could make an array of blocks and be like, oh, we want 30, or change it to 50, and so on and so forth. That's not going to be very useful for our case. So up here, we're actually going to do a hash include vector. This is a unsized array. This is going to allow a lot of stuff. So here we're going to do an std, or standard, I should say, vector. We're going to take a vector of pointer block and call it blocks. Over in the, how do we want to call this? We'll just say generate terrain. Inside, we're also going to do like a void init here. And inside this init, we're going to say blocks equals new block. Let's see if that works like that. It does not. I wonder if we do it like this. Block new vector. Yeah, I didn't think it'd be that easy either. Well, hold on. Do I get lucky? Nope, that's fine. Let's think about this. So up here, we're just going to say like blocks dot push back block. I wonder if, yeah, for now we're not going to use a pointer, just for my brain's sake of you know, I'm curious now though. Does it work if I do it like that? Or is the pointer after like that? Or is the pointer all before it? Or is it an operand like that? I don't know what that does like that. We're gonna fuck around and find out though, I'll tell you. So yeah, we're gonna initialize by pushing back blocks. I almost wonder, we don't want to do that there like that. I'm gonna Control X, Control V that over there. Trying to kind of arrange my thoughts, because what we're gonna want to do is add to this list So like we have this, we're going to add to the list, and then we're going to display the list. So just out of curiosity, so we're going to do like drawable. I'm going to pass in the render window reference, and I'm going to do Control KD to kind of fix my indentation there. And we're going to do, well, you know, I think we need drawable. I'm going to try something stupid because this is something I'm not sure how I'm going to go about it. And like I said, this is going to be a good learning experience for me and the people watching, potentially. So just kind of looking, especially on this on collision thing here. What I'm going to do is just a slash star, come down. Actually, that's one way to do it. Another really simple way is just, let's not call the function. I will say though, probably just best to do this in case of compile errors, because we're about to remove that block. So let's just do it like that. Doing it here too, really doesn't matter. We're going to take out block here. So we only have player. We're going to take out block here, and instead we are going to put in terrain. And we're going to call that blocks. Let's see what happens here. Above the player, do like blocks dot. I want to say we're going to want to do initialize. Also, let's not mess this part up again. Blocks equals new terrain, like that. The reason I'm doing the initialize is under basic, that's where we're setting things active. We want to be able to see it drawn to the screen. We're going to get rid of this initialize. We don't want it to accidentally call that one instead. And I want to say, let's leave out terrain generation for a second, or generate terrain. Oh. Thinking. Yeah, actually. Sorry about that. Put back in that. I know. Hard to follow. I get you. We're just gonna do if blocks.size is not equal to 0, and then for, and then I'm going to hit tab twice. I'm going to change this to an integer, and here we're going to do that blocks.size again. So blocks.size. Then we're going to say blocks, and then do this little square bracket, I dot init. So this is calling that basic entity initialization block here. And in fact, we're going to want to call generate terrain first. I'll show you kind of what happens if we don't. So save, hit play. We're either going to get some type of error here that requires I value. Interesting. We're just going to take out the pointer. We're not going to worry about that mess. That happens because that has a pointer stuff instead of a dot. Go ahead and hit play. Right, no terrain. This is because this list is empty. For example, if we were to go like this and hit play, we might get a vector out of range error. No, we didn't. That's fine. I'll just put that back for a minute. When we call this, it should push that block into here. So let's go into game. Before initialize, we want to call blocks.generate terrain. Go ahead and hit play. We should see one blue square. Huh. Well, that's nice of it. Oh, we never called drawable. So interestingly enough, I wonder over here if we do like blocks dot, and look, there's no drawable, so I'm gonna just kind of write one like this and go like that with window, and it looks like my initial instinct was correct, but I also not only was second guessing myself, I thought this was already accounted for through the, and the reason that's an error, that's a capital S, I thought this was already accounted for through the basic entity draw function. However, I was not, the same thing with the initialize has to happen, so that's on me. That way, instead of blocks.init here, we're going to do blocks.drawable and pass in window. Just check in. Yeah, that's unnecessary because drawable is already handled. Hit play, we should see nothing, or an error at least. Drawable must have a class structure union. Blue. Yeah, we don't see anything because again, going back, we did not generate the terrain. We did not push anything to the vector. Now when we do it, at least I very much hope so, that we should see at least something appear on the screen. Right, and there it is. But we need several of these guys. We don't need them all in the same place type of thing. And so how are we going to handle that? Well, there's a few ways, and I think one of the better ways is some type of randomization, right? We want to set the position of these blocks based off of, a certain section, a certain rule set, at least. So we know that they're like 20 by 20, doubled. Let's just kind of come down here and under initialize, let's try to just kind of like set I like this. So body.set position. Oh, yep, we're going to need blocks, and that's where the I is going to be. Dot body dot set position, and this is where we're going to need some stuff. And just for like a simple thing here, I'm going to say, let's just leave it as 200 and just go like plus blocks I dot body dot get size. Let's see what happens here. Plus does not match these operands. So what I'm going to do, blocks.get body, we're going to do blocks body get size, and I'm going to save this in a vector called size, and we're going to add 200 plus size.x kind of see what happens there. In here, we're going to say 4. And I'm going to say for int I is less than 2. So 0 and 1. Let's see if we get 2 blocks to appear. So that's what I'm thinking would happen. And then they should be right next to each other. I see 1 block. So we're initializing. Size is this. We're setting the body. Let's try like that. See where things go. There's 1 there. No, where is our other guy? Generate. So we push back. There's 1. So let's kind of follow the logic, right? So like we pushed back the block, the idea of a block into our vector. We then look for initializing. So this is number 0. We initialize him. We find the size of 0. We then, for that 0 guy, we set his position 200 plus that. Then again, what happens? It's right. It's the next. They're being placed on top of each other because they're both the same size. They're both the same position. That type of stuff. So how can we go about making sure it's different? So like for example, I'm just gonna go like this real quick. And we're gonna see if we can get 2 different ones. Of course, we're not gonna want to go 0, 1, 2, blah 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 to infinity. But yeah, we got 2 different guys. They were just on top of each other. And yeah, we're gonna have to figure out a way to handle setting these to different positions. So one thing I'm gonna try is 200 plus x plus this. I don't even know what plus I. We're gonna see kind of a weird thing happen here, perhaps. So I'm thinking the size. Let's think about this. We have the position we want. So like some starting position. Maybe call that like 0 or whatever. And then we have the size of the object. But we want to kind of offset it by that. So I'm going to do like 100 times the size of the object. See what that does to us. Probably the same place for everybody, yeah, and they're probably... How to go about this? We're setting the position of each guy. Each guy needs to increase this number by a little bit. That size thing there does not matter. I almost in some ways kind of want like, this might seem kind of weird, but I'm going to try like int offset, and we're going to say offset is 0, and up here we're going to do plus offset, and then we're going to say offset plus equals, let's try the size in the x direction plus our 100, and we'll see what happens here. Hit play. Boom, we got 2 guys. Now that offset's a little big, so let's just try by that. Hit play, See if it like pops over right next to. I'm not sure if that's quite even. Nah, it's not quite even. It's close. So we're going to do like offset times 2. That should be pretty close. Yeah, I mean, it's pretty close, if not perfect. So, okay, we have this terrain somewhat generating, right? But we definitely don't want it to only be 2. So up here, I'm going to pass in an int. We're going to call this numblock. And that way, in our terrain generation, we can kind of say, hey, we want to pick the number up here. So like if I say 10, for example, and we hit play, we should have 10 blocks. Boop. But also, what about that collision we made? What the heck, Brett? Why did we... Well, check this out. So we're going to come over here. And notice that block dot body. He's he's in a bit of a rough shape. So we're going to, up here, kind of say if blocks dot so blocks dot size. Now that's a little of a tongue twister, but we can fix that in the future. So if it's not 0, and then we're going to do a for loop. And this might be, after a while, like this might slow down the game a little bit because we're checking for all the collisions at once, but for now, this should be fine. So blocks.size. Then that whole thing. So pointer blocks.size. And then here, this is where we're going to want to have that blocks I dot body, kind of like that. So I'm going to come down here, we're going to grab all of this, we're going to control X, we're going to shove it inside this for loop, and then we're going to fix some stuff if needed. Don't see any red, hit play. We're going to come down. None of that is happening. And is this because we didn't call on collision? Doesn't look like it. Let's hit play with it being called. And looks like we have collision with every block. So fantastic, right? We did a very simple terrain generation. We did some inheritance, a little polymorphism. We created a definition of what a block is. We created an instance inside of a unsized list of that block. If you have any questions, please leave a comment. If you hate the way that I really don't know exactly what I'm doing, let me know. You know, I think that's a fair opinion. If you guys have an issue, yeah, just absolutely let me know. Join the Discord if you want. I'm part of a few different game development Discords. I am part of the Aaron Codes Discord. Aaron does stuff. I'm pretty active there. I'm also part of Pixel Pete's Discord. I'm also pretty active there as well. And we're going to just keep making videos. Slowly but surely, we're going to continue this series. Next video, we're going to be going over a little more robust system. We might think about adding like a hash include random or another randomization library. And just so you know, after you save all this stuff, you can always go to GitHub all the things that have changed, you can go ahead and say, hey, give it some type of name, commit to main. Be like, oh, hold on, we got like some type of thingamabob happening. Well, maybe it's because the file's still open. So file, save, close. Kind of check here. What do we got going on? Yep, so files open it and like it. Go ahead and push to origin. And this will commit your changes that you made. If you like the idea of a kind of a slower tutorial series where maybe the guy teaching doesn't really know absolutely everything, let me know. I'm going to continue either way. Thanks for watching.